We'll take a break around 10. We'll take a break around like 10, 15 or so today. Okay. So any questions from this you want to ask right now, or do you want to just kind of just do a bunch of problems? If there's anything that's burning, like, okay, I really looked at this last night, I have no idea how to do this problem. Please help me. Okay, well, then we'll just talk about these. And I'm recording, so you guys go. Will you have a question? Or sure. Actually, no, there's not tons of sharpening, but this is sharpening. There you go. Yeah. Yeah. Okay, well, let's just look at these right now. Let's cross off that one because that one's kind of weird, but 3 is a good one. How would you go about solving for x? If you're told they're similar and you want to solve for x, say 15 and 30, 6 and 12, and then you have x to 18, or sorry, 15 to 6, 30 and 12. Or another way to think about it too is that what's the ratio between 18 and 6 here? Is that 3 to 1? Should we expect the same thing here? So what do you think x is going to be now, based on what you see? On that ratio. So that's 3 to 1, from hypotenuse to vertical leg, assuming the right triangles, I guess. What do you think this will be? What's that times 3? I know you guys can do this. 15 times 3? 45? Okay, good. All right. 45. By the way, these two triangles are impossible. Does anyone know why? I mean, these two sides, yeah, these two sides can't equal that, right? So that's actually physically impossible. But 1 and 2, I'm not going to ask problems like 1 and 2 on the final, but it's a skill that you need to do. Well, good. Oh, this is the review number 2. Yeah, I think I gave this to you guys last week. So you just multiply these two together. That's not that hard, right? Oh, come on. So x is 8. So yeah, not that hard. That's just a skill that you need to do, like to do the same thing, but we'll move on. Okay, more about similarity. Actually, these next 4 problems are all on similarity. 5, 6, 7, 8. Okay, and I don't mind kind of just going over all this stuff with you guys right now. Then you guys will have a chance to do practice on your own when we do the Jeopardy game. Okay, let's see here. Determine whether rectangles are similar, so write the similarity ratio and statements. Okay, so if you look at MP and RU, that's 6 to 10, obviously, right? And then let's circle with a different color. So are those the same? Are those two fractions the same? What does this reduce to? 6/10. 3/5. Does this also reduce to 3/5? Yep. Then they're similar, right? So the answer is yes, because they're both 3/5. So when you write your statement, you would say this: M, P, O, N. I mean, you could have done MNOP or OP, MN, I don't really care. But since I'm going from top left and going counterclockwise, you can write it like that. So MPON, RUTS. So that's a very similarity statement. Oh boy, that is really hard to read. You've got to be kidding me. Okay. Okay. Oh goodness. I'm guessing this is an 8. Yeah, I guess it would have to be an 8 because that's 15 to 20. So we're assuming that these are similar. So if that's 15 to 20, let me erase. Okay. So that's an 8. So your ratio is either 15 to 20 or 6 to 8. What do each of those fractions reduce to? 15, 20, or 6 to 8? 3/4. Thank you, Will. 3/4. Thank you. So what this means is that you have to apply that scale factor to all the other parts. So if that's a 4, then that's a 3. So z is 3. If it's 3/4, then x is 7.5. And if that's a 9, I'm guessing it's a 9. Gosh, I really don't know. Yeah, I'm gonna say it's an 8. So we'll say that's a 6. So yeah, that's all for that one. Okay. So more of the same. These are similar triangles. How do I know that? That's because these angles are the same. And also these are going to be the same, right? Because they're vertical angles. So once you have two pairs of angles that are the same, it's enough to say they're similar. So we can see that the x and the 12 have to go together. So 2 and 6. If you work it out, you should get 6x equals 24. X is 4. And likewise here, that is the same as that. So I can say x over x plus 8 equals 3/7. X over x plus 8 equals 3/7. If you cross multiply, and work it out, you get 6. That's a good problem too, number 8. That's a very good problem. You can see on the final. So you have to realize they're similar, right? Because how do I know that? Well, you know that because these are parallel, right? Because that symbol, you see? That means that this angle is the same as this angle. And both triangles share this angle. So you have small and big, and this angle is the same as this, and this is the same as this. So that's how you can tell. I mean, are they right angles? I don't know. But at the very least, have two pairs of angles are the same. That's enough to say they're similar. So the small side to the big side, small side to the big side. All right, so that's the similarity. Pythagorean theorem, you will see. That should be actually kind of a gimme. X squared plus 6 squared equals 10 squared. I think you guys can figure that out, but not that hard. X squared plus 36 equals 100. X squared is 64. X is 8. Not that hard. Yeah, and then 10 do the same thing. 10 is gonna be a weird decimal though. I think it's a 5. I can't tell. Equals 56, I think. Yeah. So x is root 56. Sorry, my handwriting stinks here. Okay. So that's the first page. So Pythagorean theorem, some triangles. Actually, yeah, let's do this. Let's make a list of topics. That's not good. In fact, actually, maybe it's not such a bad idea to write down some of these topics and making sure that you know these topics. And you can even do a quick Google search, and usually there's a lot of resources like all those questions. I mean, there's like Khan Academy. There's what's it called? Purple Map, kind of a weird name, but there's a lot of like cool. Actually, if I did it right now, Purple Map, similar triangles. Yeah, it's kind of a cool resource where they kind of explain to you the topics and work out some examples. And then if you want to like search, like, okay, let me do Pythagorean theorem. And then you just click on that. and explain, and it even embeds videos too. So that might not be such a bad idea. Just kind of jog your memory a little bit of what we did. So, but those are 2 topics so far that we've erased, right? Okay, let's keep moving. These next 4 are going to deal with the 30, 60, 90 ratios. So special right triangle, that's the other topic. Special right triangles. And for those who are zooming at home, yeah, I'm not sure if you see, great. Not sure if you can see the board, but yeah, you can see how the way there. Position that. Yeah. So I'll make sure you guys have access to that list also. Okay. Let's keep on moving. All right, special right triangles. What's the story with that? Okay, in case you guys forgot, if you go to your notes, just to make sure I'm covering things that we have done. Yeah, Pythagorean Theorem. There we go. We did that in chapter 7. Sum of triangles, just talked about that. Special right triangles, we're talking about that right now. Then we did trig after that. So this is good. This is all good stuff. So let's talk about these 4 guys. Well, if it's 60 degrees, you could use trig if you want. Totally up to you. But I would do this. That's 60. That's 30. That's a right triangle. Excuse me. So that's S, 2S, S root 3. You totally can do that. So that means that this is 11 over root 3. No, no, is that right? No, that doesn't make sense. No, it's 11 root 3. And that's 22. Because it follows this pattern, right? S, S root 3, 2S. So you guys have it to do this. Or, and I'll give you guys this link. It's a really good link. Just type in um, 30, 60, 90 triangle. I don't know why the search bar got so small. Okay, that's weird. There we go. 30, 60, 90. Okay, that is getting really weird. Special right triangles. Here we go. That's weird. Okay. I wonder why it's acting up. If I did sine, there we go. Yeah, at least you have that's right there. So again, you have all these resources, right? But let's go back to this again. Next one here. If that is 6, that's gonna be 6 over root 3. And that's gonna be 12 over root 3. The reason why is that if you have it set up like this, right? Again, that's S, that's 2S, and that's S root 3. And that right here is 60 degrees. 60 and 30. Okay. Oh, there's Cameron. It's weird, but the 6 lines up with S root 3. So 6 is S root 3. S is 6 over root 3. And you have 6 root 3. I don't think I've taught you guys that, so don't worry about that stuff. And I don't think I'll do one quite that complex with the radicals on the final. If there's one on the hard copy, I'll change it. 13's more the same, but this is a 45, 45, 90 triangle. So in case you guys forgot that, it's just this S, S, S root 2. Naturally, these 2 sides have to be the same. Why are these the same? Because both these angles are the same. So these have to be the same. And if you can factor here, you get S root 2 for my box. So 10 is S root 2. 10 is S root 2. So S is 10 over root 2. And don't worry about simplifying. I'm not going to ask you to do that. 14 works the same way. If these are the same, then that's also 6 root 2. And X is 6 root 2 times root 2, which actually will be 6 root 4, which will be 12. So that's how you'd use those ratios, right? And again, those ratios are on the formula sheets. You don't have to memorize them. They're right here. Obviously, it's the writing's hiding it, but it says special right triangles right there. So you have them right there. Just have to use it. And again, like even if this purple math site, I don't know why it's not doing the special right triangles, but if you do special right triangles, you'll find enough resources here, right? Khan Academy or other stuff, Wikipedia. Yeah. Or if you want extra practice, I find this site, it's called Kuta. I don't know where that comes from, but if you type in Kuta worksheets, type in the topic, it gives you plenty of practice problems and all the answers. I use these worksheets all the time. So that's all good. Okay. So special right triangles. Then we have sine, cosine, tangent, right? I'll call this, excuse me, trig. So expect a decent amount of problems on these 4 topics, like maybe at least 1 for sure, maybe even 2. And maybe these topics are kind of infused into other problems, right? So this is kind of like the foundation for the second semester of geometry, right? It's all from our unit we had right after our second unit test, right after July 7th. Or after our midterm, that's what I meant to say. Yeah, so like if you guys forgot, you want the cosine of y, right? K. What does the A and H stand for? What's A? Adjacent. And H is, so what's the adjacent to y here? Is it 15, 12, or 9? And remember, adjacent has to be a leg, not a hypotenuse. So we only have 2 choices, either 12 or 9. Which one's closer to y, the 12 or the 9? The 9, right? And which one's hypotenuse? 15. There you go. That's it. And if you reduce it, not hard, 3/5, you can use a calculator. Here on tangent of A, so that's TOA. Okay, what side is opposite angle A? Clearly 2. What's the adjacent? 4. There you go, 1/2. Not that hard. If you have to solve for angles, or you have wacky angles like this one here, 43 degrees. So you have to first figure out, okay, which one am I going to use? The sub, the cut, or toe. So that's a little more challenging. 15 and 16 are a little more challenging. Oh, they're the same numbers. These next 2 are more challenging than the previous 2. But X is clearly opposite. 25 is clearly hypotenuse. So which one uses O and H? Not the TOA, not the K, the sub. The sub uses O and H, right? So you can say sine of 43 degrees equals X over 25. And I trust you guys can do the algebra just fine. I'm not worried about the algebra. But you multiply both sides by 25 and get the answer. 16. You have X degrees, so you don't know what X is. But 13 is clearly opposite. And 9 is clearly adjacent. So O and A, which one uses O and A? TOA. So you can say tangent of X degrees, excuse me, tangent of X degrees equals 13 over 9. And then how do you solve for X? You have to do an inverse tan. And how do you access inverse tan? In the calculator, right? The graphic calculator. You could also do it on your, you can do it on your cell phone. Here, I'm gonna pull my cell phone right now. Oh, someone just texted me. I think it was Neil. He's on Zoom, so that's good. All right. So yeah, if I go to the scientific mode, yeah, it's right here. I know you guys can't see my phone, but I do see an inverse tan. it says ATAN. I think most whether you're Droid or Android or iPhone, it works. And if I do 13/9, yeah, I get 55.3 degrees. That's 13, by the way, sorry. Oh, goodness. Yeah, so you get 55.3 degrees. There we go. So don't worry if you don't have a graphic calculator available. Your cell phone will be sufficient. Totally works. Okay. Hopefully that's all good. You do the same thing for the next two. In this case, that's 19 was weird, so it's just I think I crossed that one off. But here, that's obviously an adjacent and a hypotenuse. So you use ka. So cosine of 65 degrees is 10/x. Now, when the variable is in a denominator, you still multiply both sides by x. Still multiply both sides by the denominator. Don't change that. But it's one extra step in the algebra, because what you're going to have to do is then divide by cosine 65 to get x all by itself. And you'll be okay. You'll be okay at that point. Okay? 18. Tangent. Opposite. Adjacent. You can say tangent. So tangent x degrees equals 8/15. And remember, you have to do an inverse tan to isolate. Whatever trig function is next to x, if x is an angle, you have to use an inverse trig function. You should do the inverse of whatever you see. And again, it's in the calculator. Your cell phone could do your graphing calculator. If you do in the graphing calculator, let me pull that up really fast. 20, 21, 22. Math departments. Yeah, you can see over here if I hit the second button and tangent. Hard to see. You can see it shows up right there. And make sure you're in the right mode. So I do need to switch that over to degree mode. I think the graphing calculator automatically does degree mode for you. Sorry, the cell phone. So yeah. Actually, why did I close? I might need that later again. Let me go back one more time. Sorry, that was dumb. Come on. Minimize. Clear it. Okay. And the 20 is kind of more the same thing. If that's 15 degrees, that's 15 degrees. And by now, you guys get the point what to do. In this case, you're going to use a tangent again. Tangent 15 degrees is 300/x. You solve for x. Okay, so that covers a good portion of what we've done. So that's pretty much chapter 7 in a nutshell. Yeah, I don't think there's really much more to it. We didn't do lost signs. Don't worry about that. We didn't do 7.8. So, okay. I forgot what chapter 8's about. My memory's not serving me well here. Oh, polygons, right. Okay. 4-side figures. I don't know if this review has stuff on that. Kind of, it's looking at getting into area right now and volume. Yeah, unfortunately, this review guide does not cover that. I don't know why, but you do need to know that stuff. So, but let's just move on to what we see here. This is more recent. I think this is chapter 11 stuff. So yeah, you gotta know area of quadrilaterals. Circumference and area of circle. Area of regular polygons. Yeah, it looks like all that's been covered here. So first off, you got a triangle. You have to find the perimeter and the area. And what kind of triangle is this, by the way? It's right. So how do I solve for x? What am I going to do? You have to do Pythagorean theorem. I'm not going to give you one this complex because it is going to involve some pretty nasty factoring. We haven't done nasty factoring in this class, so don't worry about it. I probably would just tell you what the sides are and just do it. But you have to solve for x, unfortunately. I'm not going to work it out because I'm not going to give you guys one this crazy. But yeah, you got to go. Yeah.
No.
Oh, go. Yeah. Perimeter is easy. Add the sides. Area is easy. 1/2 BH. And what's B? And what's H? There we go. But for this particular triangle, if it's a right triangle, one decides to do the base, the one perpendicular to height. So they automatically serve as base and height by default. But again, I'm not going to go on this complex because the Pythagorean theorem is a little tricky for that one. Here, area parallelogram is BH. There's a B. There's your H. However, you're not told what H is. They just put as a letter, right? How do you solve it? Well, they did give us this, right? And I lied. The base is not 6. Base is 12, actually. So how would you solve for this height? It's going to be 8. That's a special, sorry, it's one of the Pythagorean triples. Yeah, it follows the 3, 4, 5 ratio. 6 squared, 8 squared, and 36, 6 squared has 100, 10 squared is 100, so it works. So that's how Pythagorean theorem is being confused into another topic, right? So it's a multi-layer problem, where it's just something you just can't forget. And you get 96. Because the base is 12, and I need the height. And my base was actually right there. That was my base. Okay, and again, this is where the formula sheet is going to help you tremendously, right? Like, you got all these formulas right here, right? Area of a trapezoid right there. That's the next problem. So how do I find that area? Well, 1/2. 11 plus 16 times 4. It's not that hard. Just work it out. You should get 54 if you do it correctly. And use a calculator, please. Rectangle, that is so easy. That is like a softball question. Multiply that out. That's what, 96, 102? Yeah, I think it's 102. Circumference and area of a circle. So circumference is 2 pi r. Area is pi r squared. And your radius is 6.5. Oh, you guys can't see that. Excuse me. Again, I totally trust you guys to do that just fine. Not worried about that at all. Excuse me. Okay. So A-okay there. We're good. All right. Now 5 is the one that I know kind of tripped you guys up on our last test. And again, don't worry about those two. If you have a hexagon, clearly has 6 sides. I totally cannot read that. I think that's a 4. And I didn't draw that 4 very well either. Let's say it's a 4. That's much better, right? Okay. That's also a 4. And this is also going to be a 4 too. How do I know that? How do I know that? Because it's a hexagon. Remember, if you make 6 triangles, all these triangles are going to be equilateral. Why? Go all the way around. 360. Divide by 6, 60 degrees. So guess what? That's 60 degrees. That's 60 degrees. And that is 60 degrees. So the area 1/2 apothem times number of sides times length of each side. I know there's 6 sides. I know length of each side is 4. The apothem's a hard part. This is the part that people don't like. I don't like it either. But hexagon makes it a little more manageable. Remember, you have an equilateral triangle. Each side is 4. Again, how do I know it's equilateral? Because that was 60. And these two have to get split equally because these sides are the same. Make it equilateral. So that's why the base or the side of the hexagon is the same as the radius of the hexagon. Okay. Well, if that is what's happening, what happens if you split it down the middle? That becomes 2. That becomes 60 degrees. That becomes 30 degrees. This is how one of the previous topics is infused. Special right triangles is infused into a later topic, right? You just follow the ratios. That's 2√3, or do Pythagorean theorem. Either way, you're using an old topic to understand a newer topic. And that's the apothem. So it's 1/2 times 2√3 times 6 times 4. Work it out. The 2's cancel here. You get 24√3. That's the area of hexagon. Now, what if we're not a hexagon? What if we're a pentagon or an octagon or whatever, or heptagon or nonagon, decagon? A whole bunch of options, right? Unfortunately, you would have to do some trig, and it can get a little more involved. I'm not going to do that to you guys because I think it's a little too much. And also, you'd have to use this formula as well. You have to figure out what each interior angle is. So you have to do this over here, but I'm not going to do that. Hexagons appear to be much more manageable. So I won't give you guys anything that's outside of a hexagon. And actually, who's on? Okay, camera 0 2. Okay, great. All right, let's keep moving. Let's look at these two, and then we move on to solid geometry. But I might actually jump to this part because this is something we did a while ago. Yeah, the circles are good. I still need to go back and talk about some of the basics about quadrilaterals, but these two here, we did as well. So arc length and area of the sector. We've done all that, right? Graph find arc length, find area of the shaded region, right? Not that hard. All you do is this: you do 130 over 360 times 2 pi r. Or here you do 130. Oh, sorry, I meant to say 80. 80 over 360 times pi r squared. Again, the general formulas are this. Come on. Oh, I'm not sharing my screen, sorry. The general formulas are this. What did I just do? Gosh darn it. Let's do it again. Arc length is this. Theta over 360 degrees times 2 pi r. So it's 130 over 360 times 2 pi times 2. Or you do this. Theta over 360 times pi r squared. So it's 80 yeah. And again, I trust you guys can do the math and not worry about the calculator part. But just find the formulas, right? And those formulas are provided. Right here. So it says to measure 360 or 2 pi r, or measure the angle 360 pi squared. All right there on the reference sheet, which I'm going to produce copies for you guys later today, later this morning. Okay, any questions on that stuff? No, we're okay. All right. I'm going to come back to stuff in a little bit, solid geometry. Let's look at this stuff here. So chords secants, and tangents. I kind of lumped it all. I think those are all separate sections. I kind of lumped it all at once. I don't know why I did it, but this other reference sheet, which I'll also produce, you guys already have it, but I'll do it again for you guys. Has it all here. So you got to just constantly use these formulas. I'm just gonna kind of tell you what to do because I don't want to keep going back to the formulas, but just have to use the formulas. Like in this case, that's x. Let's go red. X is half of 130 minus 50. If that's 140, that's 120. That's going to be 260. That's 100. So x is half of 140 minus 100. If that's 90, then all of this is going to be 270. So that's going to be half of 270 minus 90. Again, same thing. X is half. I'm surprised it is 4 times. It's kind of repetitive. Yeah. If you don't get it by now, then I don't know what to do. That's all you do. Like if you have 2 tangents or 2 secants or whatever, or tangent and secant, it's always going to be the same. As long as the angle's external, right? The angle's out on the outside. And okay, I'll look at the formula sheet. Yeah, it's half of what you see there. Tangent secants, 2 secants, half n minus n. Okay, hopefully that seems okay. And again, just work those out. Not that hard. For 5, so if that's x, that's 360 minus that's a tough one. That's 360 minus x. This part right here. So what are you going to do? You're going to do 70 is half of the big angle minus the little angle. 140 equals 360 minus 2x. 2x is 220. X is 110. Yeah, if you're going to do the big arc minus the little arc, it has to do this. So 5 is just similar to 1, 2, 3, 4. Just that 5 is a little more advanced, I'd say, just because you had to figure it out as 360 minus x, then solve for the arc, so solve for an angle. These here, x will be the average of these two. So 1/2 of 80 plus 60, I think. Arc AB, I don't know that, I'll call that x. So 85 is half of 90 plus x. So yeah, that's all. Here, you're gonna say x times 6 equals 4 times 9. Let me move. Let me readjust this 1 sec. Okay, there we go, perfect. Yeah, here you're gonna say 6 times 4 equals 5x. You're gonna say that's gonna be 10 minus x. Excuse me. That's 10 minus x right here. So you're gonna say x equals, gosh, I cannot read that. I think it's an 8. We'll say it's an 8. I don't know. And that becomes a quadratic, by the way. Will that make sense? Yeah, I guess so. You gotta go, Phil. Okay, I'll see you on Zoom tomorrow morning. Okay. Yeah, great. See ya.
Yeah, thank you.
0 equals x minus 6, x minus 4. So x is 6 or 4. Yeah, that makes sense. Okay, I think that was an 8 then. Because then those numbers work out nicely. Otherwise, I don't think they would have worked out as nicely. Okay, so that's all that stuff on circles. Hopefully that's okay. So that's a lot we've talked about. Like this is all chapter 7 stuff. This is like chapter 11 stuff here. That's chapter 10 that come lumped all together. Or more. Okay. Let's wrap up this stuff here. Not yet, but we'll yeah, let me tackle these next few problems and I'll give you guys a break after that. So we'll do a break around 10:15. Or 10:10. So this case here, you have 8 times 8 equals 4 times 4 plus x. That was using this formula. So here we go. Yeah, right here. A times b plus c. It's using that formula right there. Here you have 3 times x equals 4 times 4 plus 8. So you always do the external times the whole thing. External times the whole thing. For 13, 7 times 7 plus x equals 8 times 8 plus 6. And just work those out. I trust you guys can do the algebra just fine. Not worried about that. Equation of circle, which is given to you on not this one, but here. Okay, I don't know why that doesn't show up on any of these here. That's so weird. Huh. That is strange. Okay, I'll just have to, well, just look it up. It's not hard. That's so strange. Anyway. X minus h squared plus y minus k squared equals r squared. H and k, x minus 3 squared plus y plus 2 squared equals 64. Not hard at all, right? There we go. The center, your h is 0 because there's nothing to subtract to x. Your y is -4 by the way. Sorry, the y coordinate of the center or the k value is -4 because if you have y plus 4 squared, it's really like saying this, y minus -4 squared. It's really like saying that. because you have a minus built into the formula, so it's got to be -4. And the radius is root 20. So that's 15. And 17. Questions on those so far? Nope. Let me erase this other stuff here. All right. Okay. 1,2 is the center. The radius, just count it, is 3. So the equation is this. Probably a question like that on the final, also something like that. Here radius is 9. Center is -5/8. So not that hard. Excuse me. Okay. Don't worry about these here. We never did that. And don't worry about this extra credit stuff. We're not working with that stuff either. So you can ignore all that stuff there too. But yeah, so that covers equations of circles. I've got to... We still have a few more topics we need to discuss when we come back from our... We'll take a break right now. It's 10:06. So we'll come back at 10:20. We still have some more topics to talk about. We still got to talk about solid geometry. Make sure you guys remember that again. I mean, we did it 2 days ago or yesterday. Last 2 days, 2 class meetings. Also, we got to talk about chapter 8 stuff also. And if any like knick-knack stuff from chapter 11, we got to go over as well. Onia, you have a question? What's your question, Nia? You may go back.
I'm gonna leave at 11.
Okay,
Just
no problem.
No,
No problem.
thank you.
Yep. Okay, so yeah, so let's take a little break. Right now, we pause the recording. All right. So what I want to do is I want to go over the solid geometry topics. Make sure we're cool on chapter 12 stuff. But we pretty much covered chapter 7, 10, and 11 for the most part. Still chapter 8, 12 stuff I need to kind of hash out with you guys. So let's deal with solid geometry stuff right now. And then I'll kind of like handpick some questions from review number 3. So review number 3 is what you probably should work on tonight. I'm also going to borrow some of these questions, use them in the Jeopardy game for later today. So we'll actually do a lunch break probably in about 40 minutes from now, because I do need a little time to create this, because I still have to copy and paste questions. We'll talk for the next 35-40 minutes. We'll do a lunch break around 11:10, 11:15. We'll come back at 11:45. We should be done by 12:30 today. That's our plan, to be done by 12:30 today. So if you need to text your parents or your ride, whoever to pick you up. Anyway, let's look at solid geometry. So let's go back to review number 2. So I'm on the same packet we were at before the break, but let's do this page here. It's the 6th page. It's not labeled, but it's this page right here. So let's go through that. Let's see if I have any questions on the chapter 12 test review as well. And then after that, then we'll talk about some stuff from review number 3, and then we'll do a break for a lunch break. So anyway, formulas. A lot of formulas you need for solid geometry. You can see right here, a prism is just a box. That's all it is. Just length times width times height. Not that hard. But if the box does have a rectangular shape, not a big deal. Find the area of the base and multiply by the height box. That's all. So maybe you have a box like this triangular base. Fine. Just find the area. Triangle, right? If it's a cylinder, it's not a box, obviously, but like a can or like my water thing there. Circle times height. That's all. Surface area is where it gets a little dicey sometimes. It really kind of depends on the situation you're given. bottom line is that surface area is just gonna be the area of all faces, right? So if you have like a box, there's gonna be 6 faces all shaped like a rectangle, just add them all up. Or here you have 2 triangles and 3 rectangles, add all areas, right? So it just depends on what you have. I guess there's a way to generalize it. It's 2 times the area of the base. In this case, you have 2 triangles here, we have 2 rectangles here, plus the perimeter times the height. The perimeter kind of guarantees that you're multiplying all those dimensions by the height. So yeah, that's fine. For a cylinder, it's going to be the surface area is going to be the 2 pi r squared of both those circles, and the circumference times height. So 2 pi r squared plus 2 pi r h. Is that right here? For a pyramid or a cone, they're very similar to the prism or the cylinder. The only difference is that come on, go away. I was doing that. Yeah. The only difference is you multiply by 1/3 for volume. So 1/3, 1/3. For surface area, it's kind of wacky, but it's just the area of the base. And then you get like 4 triangles like pyramid here, and have all areas of the triangles. For a cone, it's the area of the base, and then pi r l, which is basically kind of like half the circumference times the slant height. And also slant height. That's what L is. That's the slant height here. And again, if you're ever confused about how that is supposed to work, let's see here. If I go purple math, surface area cone, or you just do surface area cone, but you can see well, I wish they had something worked out. They just have a bunch of formulas here, or just surface area cone. Yeah, and they label it for you, like they tell you where L is, and they actually work out a problem for you. So you have it all there. You have plenty of resources at your fingertips. Sphere, it's right there. 4/3 pi r cubed is the volume. Surface area is 4 pi r squared. So now that we've did a quick overview, let's try these problems, right? So here, you're asked to find, and don't worry about lateral surface area. That's the lateral surface area is just the side. I want the total surface area and the volume. So volume of a cylinder is pi r squared h. So pi 2 squared times 8. 32 pi. Surface area is going to be 2 pi r squared plus 2 pi r h. So you get 8 pi. But you guys can't read that. Wow. Okay, let me move that over. Hold on a sec. So that's a formula. All that equals 8 pi plus 32 pi, which is 40 pi. Okay, so it's 40 pi for that one. For 12, don't worry about lateral surface area. Total surface area, really easy. You have 6 faces. You have 8 times 4 twice. Plus, and then you have 4 times 6 twice. Plus, also have 8 times 6 twice. Multiply it out, you get 64 plus 48 plus 96. And I don't know what that is, but that's like what? 112, 202, 208, I think. Well, hold on. I trust you guys can do it. We'll just move on. So, and then volume is easy. For volume, I'll do over here. That's just going to be 6 times 8 times 4. Okay, so whatever that is, that's what, 32, 192, I think. 112, 202. I think this is 208. I think, I don't know. So anyway, so that's that. So hopefully that's not too bad. Cylinder, rectangular prism. Excuse me. Lateral surface area, again, don't worry about that. Yeah, don't worry about that. So surface area of a sphere, 4 pi r squared. Volume of a sphere, 4/3 pi r cubed. Total surface area here is going to be the square base plus 4 triangles. The volume is 1/3 the square base times the height. Here, volume is just length times width times height. Here, that's going to be pi r squared plus pi r l. That's L right here, by the way. Volume is 1/3 pi r squared h. So those are all the formulas you're going to have to utilize to do these 4 problems. I'm going to work out the set. But again, surface area and volume. These are more topics also, right, that we need to know. So let's work these out. I'll do them right below in red. That's going to be 2x plus 1 times x times 3x. I don't care if you expand it. You can leave it like that. I'm not going to ask a question like that, just so you know. If anything, I'll just give you the actual numbers. Here, the diameter is 24, so the radius is 12. The radius is 12. So you can do 4 pi times 12 squared. That'll be 576 pi. If you multiply all that out. Here, that's 4/3. Maybe a calculator for that one. That's going to be 2304 pi. So these two are done. For this one, you're told that the edge is 18. So the square base is 18 squared. You got 4 triangles. And you're told the slant height. Ugh, that's frustrating. Okay. So that's 15 right here. Oh boy. Okay, let me erase the right side. Do you guys have everything on the right side? Can I erase it? All right, let me go ahead and get rid of that because I'm gonna need some space. All right, that is a little complicated. So the triangular part of the pyramid looks like this. That's 18, and that's 15. So that part's 9. That would be 12 if you do Pythagorean theorem. That would be 12. So it's 1/4 times 18 times 12. And you work all that out. I trust you guys can do that. Here's gonna be 1/3. The base is 18 squared. There, the base, and then the height. That's gonna be a doozy. Okay. I'm not giving you guys one like this, just so you know. This is a little much. So this green segment is 12, and that's 9. So you got to draw a triangle like that. So that's 12. That was 12. That's 9. That's a doozy. 12 squared minus 9 squared. That's root 63 if we were to work that out. Yeah, so that's how 13 is a little too much, I think. Because you have to, there's a lot of extra work you have to do. Not quite sure I want to do a problem like that one, so don't worry about something like 13. It's a little much, but you should know the formula and how to use the formula. Square base plus 4 triangles. I think the surface area was kind of a fair problem. I don't think that was too bad. And I would label the sizes. Okay, well, the slant height's 15. You got to solve for the height of the triangle. Here, I think this is reasonable. Just plug and chug. That's too low. One-third by 3 squared times 4. I trust you guys do that just fine, but that'll be 12 pi anyway if you work it out. Here, pi r squared, that's gonna be 9 pi. Plus, now the height's 4, and that's 3. So you do have to solve for the slant height. That's gonna be 5 if you do Pythagorean theorem correctly. So pi times 3 times 5, you should get 24 pi. If you do that correctly. Okay. So again, more solid geometry stuff. Still, actually, I said to ignore the bottom 2, so don't worry about that. Okay, questions? We're good? Okay. Yeah, see him. Yeah, go, yeah, totally. Okay, and if we look at this stuff here from the chapter 12 test, were any questions on this that you guys want to ask about? Like find the volume of a cylinder, volume of a box. Let's look at 9 because that was kind of interesting. Surface area is this. So 44 pi. This is a chapter 12 test review, by the way. I've moved on to a new document, just so you know. This is part of the chapter 12 packet. Raised is 2. So 44 pi. So you should get that. That's a good problem. I think it's a core reasonable problem. Where, instead of just find the area, give the area, get solve for questions. And using the formula correctly. So I think that's a really good problem. If you were unsure how to do that one, that's what you do. Yeah, I think I did number 10 with you guys. Did on the video yesterday or the online class yesterday. But let me just leave it here. You guys still copying though? Okay. Let's look at 11. Surface area of a cone. So the diameter is 14.6. So raised to 7.3. Hey, Vivian, good. Sure. I'll just undo my work, no problem. Let me scroll back up. There we go. Okay. We're good, Vivian? Okay, thanks. Let's look at 11. So diameter is 14.6. So raised to 7.3. Height, of course, is 18.3. And surface area is going to be this. Pi r squared plus pi r L. R 7.3. Now the L part, again, that's 7.3. That's L. That's 18.3. How would I solve for L? What would I do? What theorem would I use? Pythagorean theorem, thank you. Yep, Pythagorean theorem. It's gonna be nasty because of the decimals. That's okay. Nothing wrong if it's nasty. I trust you guys can do that just fine. You just gotta work it out. What do I get? 7.3 squared plus 18.3 squared. Root it. You get 19.7. You get 19.7. So then you got the 19.7 over here. And you just work all that out. Again, I'm sure you guys will be fine. Not worried about that. Yeah, 12's a little much for an octagon, because that's gonna be hard to find the area of the octagon. So I'm not gonna ask you guys to do that. As well as 15. Because you have to find the area of the pentagon first. I think that's a little much. But like these here, these are pretty easy. Just 1.5 times 2.1 times 3.6. That is a strange looking 3. This one here is going to be pi r squared h. (32 pi). And wherever that is right there. So again, that should be pretty straightforward. More on pyramids and cones. Let's look at 17. The volume pyramid is this. This is a good problem. Where B is the area of the base. So what you have to do is you have to plug in 60 for the volume. Area of the base we do not know. The height's 15. 60 equals 5b. B is 12. There you go. So that should be pretty easy there. I think I already did 18 with you guys in class the other day. That I think covers it. So yeah, again, just a lot of just plugging in to formulas and working it out. Just solving what the question asked you to do. So I think we kind of beat this one to death, this topic here. The last one I'll talk about before I give you guys a lunch break, we'll do an early lunch break, is I do want to talk about quadrilaterals. Let me put this last topic. Properties of parallelograms, trapezoids, kites, rhombus, rectangle, square. That's kind of all one topic. Or that's kind of all chapter 8. So let's take a look at review number 3. So let's go to one more packet. Let's look at review number 3. And that's chapter 8 stuff. So we do need to talk about finding all the measures of angle and polygon, properties of parallelograms, properties of rhombus, rectangles, and squares, all that stuff, properties of kites, trapezoids and kites, and so forth. So, and you have all these formulas, like for the area at least, right here. But let's talk about these properties here. Okay. I'm going to jump around a little bit. So we've already done similar triangles. Okay, let's take a look at number 5. Okay, we're just going to jump around a little bit. Okay. You know, quadrilateral. What do all the angles have to add up to in a quadrilateral? We know the triangle is 180. What about quadrilateral? 360, right? So all 4 of these have to have 360. That's all you gotta do. Add it all up, and you'll get 8x. What was that? Interesting. All those numbers cancel out. -40, -30, -40, all add to -118. That's interesting. So you should get 45. And that's all they asked for. You didn't have to solve for all the angles individually, but you could if you wanted to. You could plug in like 45 for x in each angle and see what you get. You don't have to. Okay. That should be pretty straightforward, hopefully. I'm going to jump around a little bit. Okay, let's take a look at 21. Angle E and angle G. Okay. And they want angle H. Well, first off, angle E and angle G, just look at it. What do you think is the relation between these two angles here? What can we deduce about these two angles? They're the same. So, because opposite angles, that's always going to be true. That's a proper parallelograms. That's always going to be true for parallelograms. They're always going to be the same. So 8x plus 6 equals 5x plus 18. 3x equals 12, x is 4. So there you go. And then, well, you're not done yet, but if x is 4, that's going to be 68, I think. Wait, no, 52. Well, I'm losing my mind here. Hold on. 38. Geesh. 3rd time's charm. That's 38. Therefore, this is going to be 142. Because it's parallelogram, these two angles here have that. They're like same side or consecutive angles. Or you could just do 38 plus 30, which is 76, take it away from 360, and then split that. Because that's going to be split between H and F. You can do that too. That's also fine. 22, they don't give you a diagram, but if you just think about it, if you draw, and you gotta go in the order in which they label the letters, so E, F, G, H, you have to go in order. Now, F and G are not opposite of each other. And they're not going to be the same. So they'll send you to each other. Just look at the diagram. What's the relationship between F and G here? What would you say? What equation make with both F and G? They're not equal, so what other relationship can we say? Just what would it add up to? 180, thank you. 180, yes. 10x minus 3 plus 8x plus 1 has to add 180. Exactly. Again, look at your notes, it's all there. So that's a good problem too. I like that one a lot. Stuff on rhombuses. I mean, this is kind of a joke. If that's 27, it's a rhombus. What's true about a rhombus? All sides are equal. So there you go. The answer is 27. Actually, what could really help you guys, there might be a reference sheet also that we've already had. Let me just see here. 700 unit 4. Yeah, this would help a lot too. It's all there. It's if you just click, if you go to let's go to actual exams. No, I lied. And by the way, oh, I thought I put the Unit 5 test solution key up here. Hold on a sec. Huh, I thought I put it up there. Let me put the Unit 5 test solution. Hold on a sec. Braden, I know you're asking about that. Yeah, hold on, let me put it up there. That's weird. Give me a sec. Might as well just take care of that right away. Okay, but yeah, no, if you go to test resources and Unit 4, huh? Did I not put? Let me put that reference sheet up there as well. Sheesh, that's interesting. Okay, I'm glad I'm doing an audit of this. Okay. I put the reference sheet here. It did there. Okay, that's weird. Anywho, let's keep moving. Let's look at 24. If the diagonals of rhombus have lengths of 18 and 24 is the length of the perimeter. Okay, that's a really good problem. I like this one a lot too. That's a really good one. Okay, you gotta draw. Totally draw, right? So rhombus. Okay, that does not look like a good rhombus, but we'll just roll with it. You know, I could do better. Let's try that again. Okay, so you got yourself a right angle. Now, this is length of 18 and length of 24. So that's 9. And that's 9. Okay. That's 12. And that's 12. Hope you guys can see that.
It's 9, 9, 12. That is the right. That's what they do.
And then the right angles. Pythagorean theorem. I'll call this a C. 9 squared plus 12 squared equals C squared. You're going to get 15 if you work it out. You're going to get 15. So the perimeter is going to be 15 times 4, or 60. So that's a very good problem because it utilizes an old concept, Pythagorean theorem, and also the properties, right? The diagonals bisect each other, and they're perpendicular. And of course, the whole side looks the same too for a rhombus. Ooh, what's going on here? Angle JKL is 63 degrees. Okay. And it's an isosceles trapezoid. Give me one sec here, hold on. Oh, okay. Then we also know that this will also be 63 degrees, making this 117 degrees. Because they're parallel. And that's what they want. So it's 117. They want Lij. Okay, so yeah, that's a good one too. I think it's a good one also. What's the name of the sum of whose angles is 720 degrees? Or n minus 2 times 180. Say I find the sum of all angles of a polygon. So 720 equals n minus 2 times 180. You could distribute if you want. So it's 1080 n is going to be 6. So we say it's a hexagon. So that's that one. Okay. So we've seen that kind of formula before. We've done that. So that's also in one of the reference sheets. It was right here. 180 times n minus 2 sum of all angles in the polygon. I think that kind of covers a lot of that chapter. I see more triangle stuff now, which I want to infuse into the Jeopardy game today. And I see some circular stuff as well. Yeah. There's some area stuff, which I'll put in the Jeopardy game. So, okay. So I think that kind of covers everything. So it's a pretty full review we just did over the last couple of hours. So let's do another break. Let's do 7 o'clock right now. Let's do actually like a lunch break. So let's come back at say 11:40. So we'll do a 40-minute break. I'll prepare the Jeopardy game. We come back, we'll play for about like 50 minutes or so, or 45 minutes, and we'll be done by 12:30. So, yep. And so that's what we'll do the end class. So anyway, but yeah, we'll take a 40-minute break. It's 11 o'clock.
Mr. E.
Yeah, go ahead.
Um,
Hold on a second. Let me get my earbud.
Oh.
I just can't hear you because it's give me a second. All right, hold on, so I don't damage my eardrums. Yeah, go ahead, Nina. Now I can hear you.
Oh, I'm gonna leave now.
Okay, good.
Thank you.
Yeah, I'll see you later. Goodbye.
Do we have any homework or?
Nope. Just study for the final.
Okay, thank you.
All right, goodbye.